Hold out your hand, close it into a fist. Feel the bone under the skin, the heat, the weight. It feels solid, permanent, like it could never not exist. It almost didn't. That fist is here because 6 invisible numbers, locked in before the first second of time, all landed exactly where they had to. The strength of gravity, how brightly stars burn, how much push is hidden inside empty space. 6 numbers. Nudge any one of them by less than the width of a hair, and there is no bone. No blood, no sky, no child looking up at the moon, no moon. Picture a sharp pencil standing straight up, balanced on its tip. You know how that ends. It falls in a heartbeat. Now picture that same pencil staying up, not for a second, not for a minute. For 13.8 billion years, earthquakes come, it doesn't fall. Whole stars are born and die. It doesn't fall, it just stands there, defying everything. That impossible pencil is you. It's the ground under your feet. It's every light in the night sky. And we're told it's an accident, a lucky roll of the dice in an empty room. Because the other option makes the people who write the textbooks deeply uncomfortable. Funny. A shrug somehow sounds smarter the moment it puts on a lab coat. 1 precise number? Fine, flukes happen. But 6 numbers in 6 completely different corners of physics, all cooperating to make the same thing possible, all holding the door open for atoms, stars, oceans, and you. For something with absolutely no plan, the universe shows up suspiciously on time. So let's stop being polite and look at the numbers. In 1999, Britain's Astronomer Royal, a man named Martin Rees, wrote a small, quiet book called Just 6 Numbers. He didn't invent them. He just pointed at them and said the thing nobody wanted to hear. These 6 dials run the entire universe, and every single one is turned to a razor's edge. Take the first dial. Call it the cosmic thermostat. It decides how much of a star's fuel turns into light when it burns. Its value is 0.007, not 0.006, not 0.008. 0.007. Watch what happens if you touch it. Turn it down a hair to 0.006, and the glue inside atoms goes too weak. Particles refuse to stick. The whole universe stays a cold, dark fog of the simplest gas forever. No stars catch fire, no carbon, no water, no you. Now turn it up to 0.008, and the glue goes too strong. The universe burns through all its fuel in a single flash, like a match factory struck at once. The stars die before a single planet ever has time to cool. 0.07 is the only setting where you get a universe that lasts long enough to build a living thing. Imagine a radio dial as wide as our entire galaxy, and you have to land on 1 exact millimeter to catch a song instead of static, blindfolded. First try. When a number is that sharp, you have to ask a quiet little question. Is the dice really rolling free, or is there a thumb on it? And that's just 1 dial. There are 5 more. They're worse. Here's the part that should keep you up at night. Your body is mostly carbon. Skin, muscle, brain, carbon. And carbon is almost impossible to make. Inside a star, atoms have to crash and stack in a chain that falls apart almost instantly. For it to work, there has to be a tiny hidden step in the physics, sitting at exactly the right height, around 7.65 on the physicist's scale, or the chain collapses and carbon never forms. In the 1950s, a scientist named Hoyle did something wild. He said, "I exist, I'm made of carbon, therefore that hidden step has to be there. Go find it." They looked. It was there, exactly where it had to be. A whole branch of life's chemistry, hanging on one ledge, being in precisely the right spot. Lucky, again. At some point, lucky stops sounding like an answer and starts sounding like a man sweating his way through an inspection. It gets stranger. Right after the Big Bang, matter and antimatter were born in almost equal armies, and when they meet, they erase each other completely. They should have wiped each other out and left an empty, silent universe. But there was a leftover. About 1 extra grain of matter for every billion that vanished. 1 crumb left after the entire feast destroyed itself. That crumb is everything. Galaxies, stars, the chair you're sitting in, your hand. You're made of cosmic leftovers, the tiny bit the universe forgot to delete. And then there's the worst one, the energy hidden inside empty space. the push that drives everything apart. When physicists calculate how strong it should be, then measure how strong it actually is, the two numbers don't just disagree. They're off by a 1 with 120 zeros behind it, the most wrong prediction in the history of science. And yet, the real value sits at the one impossibly tiny level where galaxies can gather instead of being ripped into mist. Picture a steel safe with 120 dials. You spin every one of them blindfolded completely at random, and the door clicks open on the first try. We're told a giant explosion did all of this. Fine, but explosions throw shrapnel. They don't quietly type in a 120-digit password. Explosions make chaos, not symphonies. So why does this one keep behaving like it was checked twice? Now for the embarrassing part. We are proud of our technology. We split the atom. We land robots on Mars. So you'd think copying the universe's most basic trick, a burning star, would be within reach. In the south of France, 35 nations are building a machine called ITER. It's a giant metal donut wrapped in supercooled magnets, built to hold a cloud of gas at 150 million degrees, 10 times hotter than the center of the sun. The bill so far, north of $22 billion and climbing every year. The brightest people alive are hoping that maybe by the late 2030s, they can hold that tiny artificial star steady for a few minutes before it tears itself apart. A few minutes. $22 billion, the best of humanity. Meanwhile, a random cloud of gas floating in space lights itself and burns steadily for 10 billion years. No control room, no budget, no software update. The sun does effortlessly every second, the exact thing our finest minds can't hold together for 60 seconds. That's the gap. On one side, our fragile billion-dollar machines that melt down if a single magnet hiccups. On the other, a sky full of flawless reactors, running on margins a trillion times tighter that never need fixing. We look at a power plant and instantly see the intelligence it took to build it. Then we look up at the night sky, running on tolerances so fine we can barely measure them, and we politely decide it just bumped into existence on its own. How much longer is that going to sound reasonable? Step outside tonight and look up. Every point of light, every breath filling your lungs, the solid ground holding you in place, all of it balanced on the same 6 numbers, each one frozen at the single value where existence is even allowed. The thermostat, locked on 0.007. The hidden carbon step, exactly where Hoyle swore it would be. The one crumb of matter that survived the fire. The safe with 120 dials, open on the first spin. The pencil, still standing after 13.8 billion years. One lucky number is a coincidence. 6 is a pattern. And a pattern is the one thing an accident is never supposed to leave behind. So here's the question the data keeps backing us into. The one nobody in the room wants to say out loud: who calibrated this, if no one calibrated it?